Okay, this is the Specialist Maths paper 2020, paper 2, Tech Active. We're going to look at short response question 12. This is a really long question. There's actually 4 parts to it. Okay, so we're going to be going through it today. It's 9 marks though, so long question, 9 marks. For a certain experiment, the number of yeast cells N after T hours in a test tube can be modelled by the differential equation. Now, this is where they've given you the partial fraction breakdown. You didn't have to work it out. So the partial fraction breakdown, show the general solution can be expressed as. So if we have dn dt is 1 over 1,000 n, 1,000 minus n. So rearrange, the 1,000 will come up over this side with the n 1,000 minus n dn, and the dt comes over here. We integrate both sides. Obviously this side's going to be t plus c. Over here we're going to use the fact they've given us the partial fraction integration. So that's 1 on 1 plus n plus 1 on 1,000 minus n d. The 1 on n is going to integrate to ln n. Now this, remember, because the coefficient of the n is negative, it'll be negative ln 1,000 minus n equals t plus c. This allows us, we can use our log laws because it's take away essentially. This is that one, take that one, to make it ln n over 1,000 minus n equals t plus c. So that's what we had to show that it could be expressed as. So we've done that. Yay us. Then we move to part B. Part B says, the scientists commenced this experiment at 9 a.m. on a certain day and observed that 100 yeast cells were present at that time. Show the solution of the differential it can be expressed as. So we're going to say let 9 a.m. be t equals 0 and n equals 100 at that time. So essentially finding c, aren't we? So we're looking at finding c. So my expression was ln, whoops, got air cons blowing it away, n 1,000 minus n equals t plus c. Subbing it in, I'm going to have 100 over 1,000 minus 100 equals 0 plus c. So ln, I'll have, well, you could have it as 100 over 900 c, or ln 1/9 equals c. Plus, perchance, depends how good you are with your logs, you could do negative ln 9 too. Where are we going? So this changes. So we've worked out c. So let's go back up here. We're going to go ln n 1,000 minus n equals t plus ln 1/9. All right. Or you could have done it with this way, either way. So I'm going to bring that over here, ln n 1,000. Actually, no, I won't do that. I could play with my logs. I definitely could go that way, but I might just go n over 1,000 minus n is e to the t plus ln 1/9. Now that's n over 1,000 minus n, e to the t, e to the ln 1/9. Now, what is the e to the ln 1/9 going to equal to? Well, that's just going to equal 1/9, isn't it? So n over 1,000 minus n equals 1/9 e to the t. I'm going to multiply the n across, the 9 across. So I'm going to get 9n, and I'm going to multiply the 1,000 minus n. Because I'm looking from what they told me, I wanted n equals something. So I need to separate my n. So that's 9n equals 1,000 e to the t minus n e to the t. So that's 9n plus n e to the t equals 1,000 e to the t. Factorise out my n plus e to the t equals 1,000 e to the t. I'm running out of room here, so I'm just going to put it, continue down here. So that's going to be n equals 1,000 e to the t over 9 plus e to the t. Now, if I look at what I'm doing here, it's looking pretty similar. Points of difference, I don't have an e to the t on the top. So what I'm going to do is I'm going to divide everything by e to the t. So 1,000 e to the t divided by e to the t, 9 over e to the t, plus e to the t over e to the t. That gives me 1,000. The 9 over e to the t is 9e to the negative t plus 1. That then is what we've got here. Obviously, I've switched the denominator. We can very easily say, okay, that's 1,000, 1 plus 9e to the negative t. So, very much using your algebra skills to manipulate that around. And then you think, wow, that's a big question. And then we go to part C. Determine the time of day when 900 yeast cells were present. Now we know that n equals 1,000 over 1 plus, can't write, 9e to the negative t. So just from part B, we're told that n is 900. And we want to solve for t. So let's just solve that. We don't need to, solve n. We don't need to simplify it anymore. 1,000 over 1 plus 9 shift e to the negative t. Oops. Close my brackets, execute, and my answer is t equaling 4.39. Now t was measured in, let's just double check, because we're saying at 9 a.m. it was time 0. T is in hours. Okay, so this is excuse me, hours. So now we know that 9 a.m. is 0. So this would be, add 4 on, 1.39 p.m. We don't do 0.39 of an hour. I'm going to go 0.39 times 60, 23 minutes. So 23, 24, hang on, I might just jump back up here. What was that? I'm going to just give a few more decimal places there. 4449. Just looking at whether I wanted to round it to 24 p.m. So I'm going to round to 24. I think is a more accurate answer for me. So at 1:24 p.m. there will be 900 yeast cells present. The scientists predict that the number of yeast cells would eventually exceed 1,200. Evaluate the reasonableness of the science's prediction. Eventually. So I'm going to look at time approaches infinity. Remembering my rule is 1,000 over 1 plus 9e to the negative t. Now, as time approaches infinity, e to the negative t approaches 0. Now, if this is approaching 0, so this is all going to go to 0, then n would approach 1,000, wouldn't it? Would be my reasoning. So I would say it's not reasonable. The scientist's conclusion is not reasonable to reach 1,200 because n limited to 1,000. So where we're going with that. And that is question 12.